Hello, everyone, and welcome back to the Deep Dive. Today, we are going to look at a topic from chemistry that actually feels a bit like a mystery novel.
It really does.
We're looking at Unit 7, specifically alcohols, phenols, and ethers. But we're going to focus on three specific molecules that are, well, absolute giants in the industry.
And it's such an interesting topic because these three molecules, they are everywhere. I mean, you're probably using at least two of them right now without even realizing.
And the stakes are very, very high here. I was reading the observable phenomenon notes in our source material, and it's actually quite scary.
It is.
Imagine this. You're in the chemistry lab. You have two glass beakers with clear liquid. They look exactly the same. They even smell almost the same. And chemically, the only difference is just one single carbon atom.
Just one very small atom, a microscopic difference, really.
But here's the thing. If you drink from the first beaker, you might feel a bit dizzy, maybe tipsy, but your body can generally handle it. But if you drink from the second beaker, the one with just that one tiny carbon atom missing, you can go permanently blind, or even die within a few hours.
It sounds so dramatic, doesn't it? Almost like a movie script, but that is the reality of structural chemistry. That small difference in structure, one carbon versus two carbons, completely changes how your body reacts to the molecule.
So that's our mission today. We're going to master these three commercially important alcohols: methanol, ethanol, and glycerol. We need to understand why one is a fuel, one is a safe beverage, and one is, that sticky stuff in your face cream.
And for the Class 12 students listening, we need to understand the molecular why behind this. I mean, why we care isn't just for safety, although that is very, very important. These aren't just names in your NSERT textbook.
Right.
Their specific structures determine whether they are used as safe beverages or deadly poisons or moisturizing ingredients.
So we're going to break it down so simply that you'll never, ever confuse them in your board exams. Let's start at the absolute zero level.
Let's do it.
Okay, so if I'm a student looking at these three names, methanol, ethanol, glycerol, and I'm just trying to memorize them, they all seem like just alcohols. How should I actually distinguish them in my head?
That's the key. You need to stop thinking of them as just liquids in bottles. The best way is to use the tools in a toolkit explanation. It's a very simple way to see it.
Okay, tools in a toolkit, like a hammer or a screwdriver.
Exactly like that. Think of methanol as a very sharp, precise tool, like a surgical scalpel. It's simple, it's small, but it is dangerous if you don't handle it correctly. It's a sharp tool.
Okay, so methanol is the scalpel. Sharp and dangerous. Got it.
Then you have ethanol. This is your versatile, general-purpose tool, like a good, reliable screwdriver or maybe one of those multi-purpose tools. It's relatively safe, and you can use it for so many things: fuel, solvents, antiseptics. It's an all-rounder.
I like that. Ethanol is the reliable all-rounder. So what about glycerol?
Glycerol is totally different. Think of it as the glue, or maybe the thick grease in the toolkit. It's a thick, sticky tool. It holds things together. It's what we call polyhydric, which means it has many hydroxyl groups.
So if you imagine this toolkit, you wouldn't use a precision scalpel to paint a wall, would you? And you wouldn't use glue to hammer a nail.
Precisely. You use the right alcohol structure for the right industrial job. And if we look at, what's really happening at the particle level, it explains everything.
Okay, let's zoom into the particle level. What do these molecules actually look like?
Let's start with methanol. The formula is COH. It has just one carbon atom. Because it's so small and highly polar, it has a very high vapor pressure.
Vapor pressure. Does that just mean it evaporates easily?
Yes, exactly. It's volatile. It wants to fly away into the air. But inside the body, that single carbon structure is a huge problem. The body tries to digest it, but it turns it into formaldehyde.
Formaldehyde. Wait, isn't that what they use to preserve dead specimens in the biology lab?
That is exactly what it is. It makes proteins hard and rigid, and that's why it is so toxic inside a living person. Now, compare that to ethanol, TACHO. It has two carbons. This size is special. It makes it amphipathic.
Amphipathic. Okay, that's a big word for class 12. Let's unpack that.
Right. It just means it plays well with everyone. It's soluble in water because of the NO-H group, but it's also soluble in liquids or fats because of that two-carbon chain. And crucially, the body metabolizes it safely into acetic acid.
Acetic acid? Isn't that basically vinegar?
Correct. So methanol turns into a poison like formaldehyde, and ethanol turns into something safe like vinegar. That is a huge difference for just one extra carbon.
A massive difference. And then there's glycerol.
Glycerol. It has three carbons, but here's the key. It has three OH groups attached to them. This is what makes it polyhydric.
So polyhydric just means many OH groups?
Yes. And because of all those ATOH groups, it does a lot of hydrogen bonding. All that bonding makes the molecules stick together, which makes the liquid thick or viscous. And it also acts like a magnet for moisture. We call that being hygroscopic.
Okay, that's a great word, hygroscopic, meaning it attracts water.
Exactly. So here's our anchor definition for your exam. Commercially important alcohols like methanol, ethanol, and glycerol have different structures, specifically the number of carbons and OH groups, and this determines their physical properties, toxicity, metabolism, and industrial applications.
Oh, we really need to clear up a common confusion right now. This is the misunderstanding trigger line.
Yes. So many students think, oh, it's an alcohol, it's just a solvent, they are all the same. You have to fix this in your head immediately. Methanol is toxic because it has one carbon. Ethanol is versatile because it has two carbons, and glycerol is viscous because it has three OH groups. They are not interchangeable.
Got it. Do not mix them up. Now, to help this really stick in our brains, let's use an analogy. We talked about tools, but let's talk about something maybe more relatable. Let's talk about a family.
Yes, this is the primary analogy from our notes. Think of these three molecules as three siblings in a family.
Okay, introduce us to the family members. Who's who?
First, you have methanol. This is the dangerous young sibling, maybe the chaotic teenager. It's small, it's immature, just one carbon, it's unstable. And because it's young and doesn't know better, it gets into trouble easily. In the body, it converts into harmful things. It is the risky one.
The chaotic, dangerous little brother. Okay, who's next?
Then you have ethanol. This is the responsible adult. It has two carbons, so it's a bit bigger, more balanced. It's safe to be around. It has a job. In fact, it has many jobs. It works as a solvent. It works as a fuel. It's the reliable member of the family.
I like that. The responsible adult who pays the bills and drives the car. And the third one?
Glycerol is the wise elder, the grandmother figure. It's complex. It's stable. And those three OH groups, think of them like the elder holding the entire family together. It connects things. It's slow-moving viscous because it's weighed down by all that responsibility and connection.
That is actually perfect. The dangerous kid, the responsible adult, and the wise, steady elder.
And there's also a quick alternative analogy if you want to think about their physical state. Just think about water bottles.
Oh, you mean like the container itself?
Yes. Methanol is like a small, open cup. It spills easily, and the liquid inside evaporates very quickly. It's volatile.
Right, spills everywhere.
But glycerol is like a thick ketchup bottle or maybe a honey bottle. It's viscous. It holds on to the liquid inside. It doesn't spill. It just oozes out slowly.
That really helps visualize the viscosity. Now, why does this concept even exist in Unit 7? I mean, why do we need to study these specific three?
Because it solves a big problem in understanding chemistry. We need to connect molecular structure to real-world impact. Without this concept, we can't explain why methanol kills, but ethanol doesn't. We need to see that chemistry has real consequences.
It's not just abstract drawings of lines and letters on the blackboard.
Exactly. In practice, the pharmaceutical industry uses ethanol as a solvent because they know it's safe. The cosmetic industry uses glycerol as a humectant, that's a moisturizer, because they know those three OH groups will hold on to water on your skin. They choose the molecule based on its structure.
Okay, let's run a mental movie. I want everyone listening to close your eyes for a second, but please be careful if you're walking or driving. But just try to visualize this.
Picture three molecular stories happening side by side.
Okay, story number one, methanol.
Imagine a lonely carbon atom with just one OH group attached. It looks small and jittery. It's vibrating fast because it's unstable. Now imagine it entering a biological system, a human body. Suddenly it starts glowing with a red warning light. It transforms into a villain. You can see toxic clouds of formaldehyde swirling around it.
A red, toxic villain. Okay, story number two, ethanol.
Now see two carbons linked together. They look balanced, steady. This molecule is glowing with a soft green, light green for safety. It moves smoothly through the system. It's a hero molecule, fixing things, dissolving things, doing its job without causing any chaos.
Green hero, balanced and safe. And story number three, glycerol.
Now, picture three carbons in a chain, but this one is bristling with OH groups, one on every single carbon. It looks like a magnet. Visualize a blue cloud of water molecules surrounding it, sticking to it. The molecule itself looks heavy, sticky, and slow. It flows like a thick syrup.
So we have the red villain, the green hero, and the blue sticky elder. If you can see that, you can probably answer most of the exam questions.
Exactly. That visualization will help you recall the properties instantly.
Let's get into the specific examples now. We mentioned the observable phenomenon at the start, the blindness. Let's expand on that. What actually happens?
Well, if someone accidentally ingests methanol, the symptoms start within hours. And it's not just feeling sick. The specific metabolite, which is formaldehyde and then subsequently formic acid, it attacks the optic nerve. It effectively destroys the cells that let you see. That is why blindness is the specific symptom of methanol poisoning.
That's terrifying. And ethanol.
Ethanol causes intoxication, of course. It affects the central nervous system. But chemically, the process is reversible. The body has enzymes to break it down safely into acetic acid, which then enters your normal energy metabolism. You might have a headache the next day, but your optic nerve is perfectly fine.
And glycerol. What happens if you drink that?
Glycerol is actually a part of our normal metabolism, too. It enters the glycolysis pathway. That's how our body breaks down sugar for energy. So if you ingest glycerol, your body just says, oh, energy, and uses it. It's perfectly safe.
Now, let's talk about technology application. Where do we actually see these in real-world industries?
Ethanol is absolutely everywhere. You see it at the petrol pump. E10 gasoline is 10% ethanol mixed with petrol. It's an additive to reduce pollution. It's also the main ingredient in hand sanitizers because it kills bacteria by dissolving their outer membranes.
It dissolves the membrane. Is that because it's amphipathic?
Yes, exactly. The lipid-loving part of the ethanol molecule attacks the bacteria's membrane.
And methanol. Please tell me we don't put the toxic villain in our daily products.
We do, but mainly in industry. Methanol is used to make formaldehyde, which is then used to make plastics like Formica. You know those hard tabletops in school classrooms? That material comes from methanol.
So methanol is good for making tables, but terrible for drinking.
Correct. And glycerol. Just check your bathroom cabinet. Face creams, lotions, even cough syrups. It's used as a sweetener and a solvent in medicines. And famously, it's used to make nitroglycerin, which is an explosive.
Wow. From face cream to explosives, that is quite a range.
It's all about those three OH groups. In explosives, those groups are reacted with nitric acid. In face cream, they're just holding on to water.
So here's a counterintuitive example for you. You might think, okay, methanol and ethanol are both small alcohols. They're liquids. They look the same, so they should be equally safe.
But actually, that is a deadly mistake. As we've been saying, the difference is just one carbon atom.
Why does that one atom change the game so much?
It changes the shape of the molecule just enough that different enzymes in your body attack it differently. It's like a lock and key. Ethanol fits the safe metabolism lock. Methanol fits the toxic metabolism lock. Biology is very, very picky about structure.
So size matters, but structure matters more.
Structure is destiny in chemistry.
I really like that line. Structure is destiny. Okay, exams are coming up. We need to give our listeners the exam safe clarity lines. These are the points from source B4 that you just have to memorize to get full marks. Could you go through them slowly?
Right. Let's slow down for these. These are your key takeaways for the exam.
Okay, point number 1.
Methanol is highly toxic. Why? Because it is metabolized to formaldehyde and formic acid. What does it do? It damages the optic nerve. Do not forget the optic nerve part.
This is important because questions often ask for that specific biological effect. So methanol equals formaldehyde equals blindness. Point number 2.
Ethanol has relative safety. Why? Because of its metabolism into acetic acid. And acetic acid is safe.
Ethanol equals acetic acid equals safe. Do not confuse acetic acid with formic acid. Point number 3.
Glycerol. The keywords here are viscous and hygroscopic. If they ask why, the answer is extensive hydrogen bonding due to 3 OH groups.
3 OH groups mean lots of hydrogen bonding, which means sticky and water-loving. Point number 4.
Ethanol's amphipathic nature. This is a great keyword to use for scoring marks. It dissolves in water because of the OH group, and it dissolves in lipids because of the carbon chain. This makes it an excellent solvent.
So amphipathic means it likes both water and fat. A great solvent. And finally,
methanol's volatility. It has a high vapor pressure. Why? Because it is small and has limited H bonding compared to glycerol. It flies away easily.
small size equals easy escape, high vapor pressure.
Precisely. If you can recall these 5 points, you are absolutely set for this topic in Unit 7.
Amazing. Okay, let's wrap this up with a short summary. If you fell asleep for the last 15 minutes, which you shouldn't have because this is fascinating stuff, here is what you missed.
Let's recap the core idea. Methanol has 1 carbon and is toxic. Ethanol has 2 carbons and is safe and versatile. Glycerol has 3 carbons and 3 OH groups, making it viscous.
Your mental picture, remember the villain, methanol causing trouble, the hero, ethanol saving the day, and the wise elder, glycerol holding everything together with those sticky hydrogen bonds.
And your key example. Methanol causes blindness via the optic nerve. Glycerol holds moisture in cosmetics because it is hygroscopic.
And the exam takeaway. Remember that structure determines use. 1, carbon kills. 3 OH groups make it sticky.
As simple as that.
So next time you are sanitizing your hands with that gel or putting on some moisturizer in the winter, think about the molecules.
Visualize those carbon chains and those hydroxyl groups doing their work.
Think about the responsible adult, ethanol in the sanitizer, and the sticky elder, glycerol in the lotion. It's a chemical family reunion right there in your hands.
And luckily, no dangerous sibling methanol is invited to that party.
Exactly. Keep the methanol in the lab and the industrial plant where it belongs.
Safe chemistry is always the best chemistry.
Thank you so much for listening to this deep dive into commercial alcohols. Keep visualizing those structures, and you will ace Unit 7. We'll see you in the next episode.
Happy studying.